Dear students, welcome back for the third session of this numerical problems with respect to a chapter that is solutions here. Okay. So now in the previous two different sessions we have solved nearly 12 numericals. Now we will move on to the numerical number 13th. What's that? 3 moles of a non-volatile solute is dissolved in 15 moles of solvent. Calculate the RLVP. RLVP means it is called as relative lowering of which pressure? Vapor pressure. We have to find out RLVP. RLVP is actually equal to P naught minus P divided by P naught. That we have to find out. Okay. Here N2 is equal to 3, N1 is equal to 50. Therefore N1 plus N2 is equal to 80. N is number of moles. Number of moles with respect to 2 means it is a solute. How many moles of solute are there here? 3 moles of solute. And how many moles of solvent here? It is the 15 moles of solvent. 15 moles of which one? Solvent. And the total number of moles of solution is equal to 33 plus 50, that is equal to this one. By which law? Rolle's law of RLVP. Rolle's law of which one? RLVP. What's that? P naught minus P divided by P naught. What is that? P naught minus P divided by P naught is called as, what is that? It is relative lowering of vapor pressure. It is equal to N2 divided by N1 plus N2. N2 divided by N1 plus N2. That is equal to. So here RLVP we have to direct calculate. N2 is what? 3 divided by 80. That is equal to 1 by 6. 1 by 6 is 0.166. It doesn't have any unit. Why? Because it is a ratio of the ratio of the pressures. Means this having a unit of pressure, this also having a unit of pressure. Therefore, the pressure unit gets cancelled. Means relative lowering of vapor pressure doesn't have a unit, and the value for this RLVP is going to be 0.166. How it is? When 3 moles of a non-volatile solute is added or dissolved in how many moles of solvent? 15 moles of solvent. On that basis, N2 is given as 3 and N1 is given as 15. And the total moles of the solution is given as totally the 15. Then applying the what law here? Rolle's law for relative lowering of vapor pressure, where P naught minus P divided by P naught is called as relative lowering of vapor pressure is equal to X2 actually. What is X2? Mole fraction of solute. How to calculate mole fraction of a solute? Number of moles of a solute, that is called as N2 divided by total number of moles of both the solute and then the solvent, that is equal to the N1 plus N2. So substitute and simplification gives the relative lowering of vapor pressure is equal to 0.166, but no unit here. Okay. So that is about the numerical number, which one? 13th. Let's have the 14th here. Vapor pressure of pure benzene. Vapor pressure of which one? Pure benzene at some temperature is found to be 0.95 bar. Calculate the vapor pressure of 1 molar solution of a non-volatile solute in it. So here we have to find out the what? Vapor pressure of 1 molar solution. Which is solvent and which is solute here? It is solvent is benzene, I think. Benzene. Having a formula C6H6. Solute is known or unknown. A non-volatile solute, therefore it is going to be the unknown. Okay. The vapor pressure of pure benzene is solvent. Solvent means it is P naught. What is P naught? 0.95 in terms of bar. It is in terms of bar. Calculate the vapor pressure of 1 molar solution. Vapor pressure of solution is P, we have to find out. What's the meaning of 1 molar solution means? Implies 1 mole of solvent means what? 1 molar solution. What's the meaning of 1 molar solution means? It is 1 mole of solute in 1 kg of benzene. What benzene is? It is a solvent. It is a solvent. 1 kg means it is indirectly how many grams? 1000 grams. It is in terms of 1000 grams. Okay. 1 molar solution means 1 mole of a solute in how much? 1 kg of a solvent. Which is the solvent here? It is going to be the benzene. So here N2 is equal to 1 mole, I think. Because how many moles? 1 moles. In W1 is equal to 1000 grams. 1000 grams. Therefore, what is N1 is equal to here? N1 is W1 by M1. 1000 divided by, what is M1 here? M1 means it is the molecular mass of solvent. What is the solvent here? Benzene. Benzene molecular mass is, carbon is 12. 12 6 are 72 plus 1 6 are hydrogen. 6 plus 72, that is equal to 78. Okay, that is equal to. So what is that? Numerical number 14th. 1 kg of solvent. Okay. So it is 100 divided by what? 100 divided by 78. Okay. So then N1 is known, N2 is known. Applied. You have to simplify that and get the value of this. Okay. We know that. What is the value for this? By which law here? Rolle's law of RLVP. RLVP means relative lowering of what pressure? Vapor pressure. What is that? P0 minus P divided by P0 is equal to N2 divided by N1 plus N2. N2 divided by N1 plus N2. First we have to calculate the value of this. What is N2? 1 divided by 100 by 78. So I will make this as X. You have to calculate on your, because I am leaving for you. 100 by 78, you have to calculate that one. So here it is X plus what? X plus 1. Okay. So what is this? It is P0 minus P divided by P0. Therefore, what is P0 minus P? P0 minus P is actually P0 divided by X plus 1. X plus 1. I need the value of which one? P. What is P here? Vapor pressure of the solution. P is equal to P0 minus, P is equal to P0 minus P0 divided by X plus 1. That is equal to P0 into 1 minus 1 by X plus 1. So simplify and get the value of this. Okay. Sir, I can mention that as X plus 1 minus 1. That is equal to P0 into LCM is what? X plus 1. So here it is X plus 1 minus 1. X plus 1 minus 1. That is equal to X. That is equal to P0 into X divided by X plus 1. So here, what is X here? It is 100 by 78. So if I simplify that X 100 by 78 and substitute the value of that in case of the vapor pressure, the P value is found to be around 14th is actually 14th is 0.9. You have to calculate on your own. Let it be Y in terms of which one? Bar. Because as it is in bar given, this is also going to be the bar. It's a work of yours right now to get the value of what by what? 100 by 78, such that you will get around 14 or 15, something like that. Most probably around it is 14 or 15 approximately. I don't know exact. Then by knowing the value of which one? X. P0 is known. What is P0 here? 0.95 in terms of which one? Bar. Okay. X is calculated. Therefore, P0 into X divided by X plus 1, that is equal to Y. If that be the case, we are getting the P value. What is P here? It is called vapor pressure of the solution. That is calculate the vapor pressure of how much molar solution? 1 molar solution. So just by observing that particular numerical, vapor pressure of the pure benzene means it is a solvent. Solvent is found to be the benzene having a formula C6H6 and its respective molecular mass is found to be 78. And at the same, some temperature is 0. Means the vapor pressure of pure benzene is 0.95 in terms of bar. Calculate the vapor pressure of 1 molar solution. Means vapor pressure of the solution means it is just only the P. P we have to find out. Okay. Then N2. What is the meaning of 1 molar solution? Meaning here it is 1 mole of a solute dissolved in 1 kg of solvent. How many moles? 1 mole of a solute dissolved in how much kg of solvent? 1 kg of solvent. Means number of moles of solute N2 is equal to how many moles? 1 moles. And it is dissolved in how much kg? 1 kg of solvent. Which is the solvent here? Benzene. Mass of the solvent is W1 is equal to 1 kg. 1 kg is equal to how many grams? 1000 grams. 1000 grams means how many moles of benzene are there? Number of moles is equal to mass divided by which one? Molar mass. So that is 1000 by 78. On simplification, I will get the value in the form of X. What X is? It is the number of moles of benzene. Okay. Now, by applying the what law here? Rolle's law of relative lowering of vapor pressure, P naught minus P divided by P naught. This is called as relative lowering of vapor pressure is equal to mole fraction of the which one? Solute. So substitute and simplify to get the value of Y. And that Y is called as what? P. What is P here? It is a vapor pressure of how much molar solution? 1 molar solution. Okay. So that is about the numerical number which one? 14th. Let's have the 15th now. Vapor pressure of pure water or water at 295 Kelvin is found to be 18.5 mm of mercury. Calculate the vapor pressure of the solution containing 25 grams of urea dissolved in how much? 400 grams of water at the same temperature. Okay. So here, which is the same concept, the P naught is given, we have to calculate the value of P. Vapor pressure of solvent is given, vapor pressure of the solution we have to find out. Vapor pressure of water. Vapor pressure of water. Water is a solvent here. Means solvent is water. Water is H2O. Vapor pressure of pure water is, pure water vapor pressure means P naught is 18.5 in terms of mm of mercury. 18.5 mm of mercury. Calculate the vapor pressure of the solution. Vapor pressure of the solution means P we have to find out. That's all. Okay. How that solution is obtained? By dissolving 25 grams of urea. What urea is now? A solute. Means solute is urea. Solute is what? Urea. Means W2 is equal to 25 grams. W2 is equal to how many grams? What is W2? Mass of solute. What is the solute here? Urea. That is equal to 25 grams. It is dissolved in how many grams of water? 400 grams of water. What water is? A solvent. Means mass of the solvent is W1 is equal to how many grams? 400 grams at the same temperature. Now, again we have to apply the same Rolle's law for relative lowering of vapor pressure, where we have to get the mole fraction. Mole fraction means we have to get the number of moles. But here there is no number of moles. Here the mass is given. First, what is N1 is equal to W1 by M1. What is W1? 400. What is M1 here? M1 is, 1 means solvent. Solvent means water. What is the molecular mass of water? It is 80. What is M2? Molecular mass of solute. What is the molecular mass of solute? Urea. It is 60. Because you have to know the formula. NH2CO, NH2 is called as which one? Urea. H2O is called as water. What is the molecular mass of water? 18. What is the molecular mass of urea? It is equal to NH2CO, NH2 that is equal to 60. That you have to be very familiar first. Okay. Now, by 18 I think. 400 by 18. 400 by which one? 18. 400 by 18. So that you can calculate. X. I don't want to write that particular name now. What is N2 here? W2 divided by M2. What is W2? Mass of the solute. It is 25 grams divided by molecular mass of the solute is found to be the 60. That is equal to Y. What is Y here? It is the number of moles of urea called as a solute, and N. X is the number of moles of which one? Solvent, that is called as water. By Rolle's law of RLVP, of which one? RLVP. P naught minus P divided by P naught is equal to N2 divided by N1 plus N2. That is equal to. What is N1 here? N2 here? Y divided by X plus Y. I am not simplified here, or I am not simplified with the help of calculator. It is your work. First 400 by 18 you have to calculate the value of number of moles of a solute is found to be solvent is found to be the X. Similarly 25 by 60 is nothing but the number of moles of a solute that is mentioned as in the form of only the Y. Then substitute and get the value of this one. Okay. R. What is P naught minus P here? It is P naught into Y divided by x plus y. What is P naught already given? It is 18.5 into y we have to calculate, x we have to calculate such that I am getting the value of P naught minus P. Therefore, what is P? It is P naught minus P naught y divided by x plus y. Okay, so substitute and get the value, and if I simplify that substitution, the final answer that I am writing wrongly, it is going to be the 18.1532, 18.1532 in terms of millimeter of mercury, because as it is a vapor pressure means it is the, here it is mentioned as millimeter of mercury, therefore the vapor pressure of the solution is going to be 18.1532 in terms of millimeter of mercury. Okay, the same concept here, the solute is different here. Which is the solute here? Urea is a solute and the solvent is going to be the water. How many grams of solute and how many grams of solvent here? 25 grams of solute added in how much grams of solvent? 400 grams of solvent. Means the mass of the solute and the mass of the solvent is given. Based on that I calculate the number of moles. How to calculate number of moles? It is the mass of the solute divided by or mass of the substance divided by respective what mass? Molecular mass. What is the respective molecular mass with respect to water? Water is a very special, that is going to be the 18, and the molecular mass of urea having a formula NH2CONH2. If I simplify that by adding the various which masses, atomic masses, I will get the value of molecular mass of urea is going to be 60. So on simplification, N1 is going to be the X moles and N2 is equal to the Y moles. Then applying the same what law here? Raoult's law of which one? The RLVP, relative lowering of vapor pressure, such that P naught minus P divided by P naught is equal to N2 divided by N1 plus N2, that is equal to Y divided by X plus Y. Okay, so therefore P naught minus P is equal to P naught into Y divided by X plus Y, or P is equal to P naught minus P naught Y divided by X plus Y. So substitute and get the final answer, and that answer is going to be 18.1532 in terms of which one? Millimeter of which one? Mercury. Okay. So that is a numerical number. How much? It is the 50th here. Let's have the 16th now. Okay, so now I'll rub this. The molar depression constant of water is 1.6 Kelvin per molal. Kelvin per molal. Calculate the depression in the freezing point of 0.1 molal with solution, aqueous solution. Okay. Here again the solvent is water. Having a formula H2O. Solute is again urea, I think. Solute is urea. Having a formula, what is that? NH2CONH2. It is the formula of which one? Urea. Okay. The molar depression constant of water. What is the symbol for molar depression constant for water or a solvent is given by Kf. What is the Kf value? 1.86 Kelvin per molal. Kelvin per molal. Calculate the depression in freezing point. Means we have to calculate the value of depression in freezing point is given by delta TF. Delta TF. Of 0.1 molar aqueous solution. Molality is given as 0.1. Molality is given as 1.1. We know that. What's the formula for a non-electrolyte? As urea is a non-electrolyte, delta TF is directly equal to Kf into M. That's all. Kf into M. That's equal to, what is Kf? 1.86 into, what's the molality given? That is equal to 0.186 in terms of Kelvin. What is delta TF here? It is the depression in freezing point. What is the depression in freezing point? It is going to be 0.186 in terms of Kelvin for how much molar solution? 0.1 molar which solution? Aqueous solution of urea or aqueous urea solution. A direct problem here. Just Kf and molality is given. We have to find the value of which one? The depression of what point? Freezing point. Okay. So let's have the question number or the numerical number 17th. Molar elevation constant for benzene is going to be 2.52 Kelvin per molar benzene. A solution of benzene containing a solute I is equal to 1. I is equal to 1 means it is a non-electrolyte. Boils at 0.12 degrees Celsius, 126 degrees Celsius, higher than that of benzene. Higher than that of benzene. Therefore, calculate the what? Molality of the solution. Calculate the molality of the solution. Here, molar elevation constant for benzene means the solvent is benzene. It is having a formula of which one? C6H6. Which is a solute? A solution of benzene containing a solute means he has not mentioned any name for that, therefore it is going to be the unknown. With I factor is given as 1. That shows that it is an example for a non-electrolyte. Already I is given as 1. Okay. The molar elevation constant means the symbol is going to be the Kb. Molar elevation constant is going to be the Kb. It is going to be how much? 2.52 Kelvin per molar. Kelvin per molar. Okay. It boils at a temperature. A solution of benzene containing a solute boils at a temperature higher than that of 1.2 means directly higher than that of means it is indirectly the delta Tb is given. What is delta Tb here? It is 0.126 degrees Celsius. Suppose if Tb naught is the solvent boiling point, if it is X, then what is the boiling point of the solution? It is Tb naught plus 0.126. Therefore, what is the difference in temperature? It is 0.16. Means directly I will write that as the elevation boiling point is given as how much? 0.126 in terms of degree Celsius. Calculate the what? Small m. What is small m here? Molality of the solution. It is not the molarity, it is the molality. So again we know that what is the formula? Delta Tb is equal to I into Kb into m. I into Kb into m. I need the value of which one? M is equal to delta Tb divided by I Kf. Sorry, not Kf here, it is Kb, sorry. I into what? Kf. Kb, sorry. What is delta Tb here? Delta Tb is directly given as 0.126 divided by E factor is 1, and what is the value of Kb here? 2.16. 2. So if I simplify that, 0.126 divided by is 2.52. If I simplify that, I will get the value of 0.05. Therefore, what is the molality of the solution here? It is going to be the 0.05. So that is very similar to that of the previous one. There, the Kf value is given, molality is given. We have calculated the depression in the freezing point. But here, elevation of boiling point constant, and then the which one? The elevation in boiling point is given. We have calculated the value of which one? Molality. This is elevation in boiling point constant. This is called as elevation of boiling point. This is also called as ebullioscopy constant or molar elevation constant or boiling point constant, and this is called as elevation of which point? Boiling point. If these two are given, we have to calculate the value of which one? Molality. Molality is equal to what? Delta Tb divided by I into Kb. But here already directly given as I is equal to what? 1. I is equal to 1 means it is referring to the which one? A non-electrolyte, because it doesn't get either associated or it may be the dissociated. So on that basis, the final value for the molality of the given solution is going to be 0.05. Okay. So that is about the numerical number. How much? It is the 17th. Let's have the 18th now. Okay, so let's move on to the 18 now. Heptane and octane form an ideal solution. Ideal solution means it is a liquid solutions. Means both the solute and the solvent are in the what states? Liquid states. Means up to the 17 numericals we have talked about only the colligative properties where the solute is a solid and the solvent is a liquid. But now there is a concept of liquid solutions. Means both the solute and then the solvent. And they form a what solution here? Ideal solutions. Okay. So at 373 Kelvin the vapor pressures of them are respectively how much and how much? 100 kilopascals and 50 kilopascals respectively. For them are found to be how much and how much? 150. What will be the total vapor pressure of the mixture of 25 grams of heptane and 35 grams of which one? Octane. Assume the mixture is behaving what? Ideally. We have to calculate the total pressure, that's all. Let A be heptane having formula C7H16 and B octane having a formula C8H18, because we know that the general formula for alkanes is CnH2n plus 2. It is the general formula for which one? Alkane. Hept means 7 carbon atoms. Therefore, it is C7H 14 plus 2, that is equal to 16. C7H16 is the heptane formula. If I put N is equal to 8, it becomes octane. 8 2s are 16, 16 plus 2, that is equal to 18. Okay. Now, at 373 Kelvin, the vapor pressures of them are respectively what and what? 150. PA naught is equal to 100 kilopascals. PB naught is equal to 50 kilopascals. What is PA naught and PB naught? They are the individual vapor pressures of the A and B. What is A here? Heptane. And what is B here? It is the octane. Therefore, PA naught is equal to 100 kilopascals and PB is equal to 50 kilopascals. We have to calculate the P total. What's the calculation here? We have to calculate the P total. That is the total vapor pressure of a mixture containing how many grams here? 25 grams of heptane and 35 grams of octane. Means W2 is equal to WA first. Let us have. What is WA here? A means heptane. Heptane is 25 grams. What is WB? That is equal to 35 grams. Okay. Now we have to find the value of which one? So here what is MA? What is MA here? Molar mass or molecular mass of A. What is A here? Heptane. What is the molecular mass of heptane? Formula is C7H16. 12 sevens are 84. 12 sevens are 84. 84 plus 1 16s are 16. 84 plus this one is equal to 100, I think. What is 100 here? It is the molar mass of A. What is A here? It is the heptane. Similarly, what is MB? MB is the molar mass of B. What is B here? It is octane. Octane is C8H18. Carbon is 12. 12 8s are 96. 96 plus 18. 96 plus 18, if I simplify that, it becomes 114. So what is here 100 and 114 are? They are the molar masses or the molecular masses of the two different liquids called as the heptane and then the octane. We are mentioning that in the form of A and B respectively. Okay. Now, what is Na here? WA divided by MA. WA divided by MA. What is WA here? 25 divided by 100, that is equal to 0.4, I think. 0.4. What is NB here? WB divided by MB. What is WB? 35 divided by 114. So 35 by 114 is going to be 0.307. 0.307. So what? NB and Na are number of moles of which and which? Heptane, that is A, and then the octane, that is called as B. Therefore, what is XA? XA is equal to what? Na divided by Na plus NB. Na plus NB. What is Na here? 0.4 divided by, add these two. I will directly write that as 707. 0.4 divided by 707. So on simplification of 0.4 0.25, sorry, it is 0.25, it is not 4, 0.25, sorry. What is 0.25 plus 0.307? It is 0. I think 557. 0.557 I think. So upon simplification I will get the value as 0.448. 0.448. Okay. Therefore what is XB here? It is 1 minus XA directly. Why? Because the sum of the mole fractions is always equal to 1. Therefore XB is equal to 1 minus XA, that is equal to 0.552. Means what I got here? I got the values of which and which? Mole fractions of A and then the mole fractions of B. We know that. What is the formula here? PT is equal to PA plus PB according to the Dalton's law of partial pressure. Dalton's law of partial pressure. But this is again equal to PA naught into XA plus PB naught into XB. That's equal to PB naught into XB. What is PA naught here? PA naught is 100 into what is XA? XA is 0.448 plus what is PB naught? It is 50 into what is XB? 0.552. So if I simplify that, I will directly write the answer. You can check out with respect to that. 72.4 in terms of kilopascals. So what is here 72.4 here? It is the total vapor pressure of the mixture containing how many grams of heptane and how many grams of octane? 25 grams of heptane and 35 grams of which one? Octane. So it is actually the lengthy process, but it is very easiest because first we have to take the two different liquids in the form of A and B, where A represents the heptane having the formula C7H16 and B refers to the octane having a formula C8H18. Okay. Then their individual vapor pressures are given. For heptane it is PA naught is 100 kilopascals. For another one that is called as what is that? The octane PB naught is equal to 50 kilopascals. We have to calculate the total pressure, means P total we have to find out. Means how many grams of heptane and how many grams of octane are taken? 25 grams of heptane and 35 grams of octane. Means WA is equal to 25 grams and WB is equal to 35 grams. Then we have to know its molecular mass. Molecular mass of heptane is equal to 100 and that of octane is equal to 114. Based on that, I will calculate the value of which one? Number of moles. How to calculate number of moles? Mass divided by which mass? Molar mass. On that basis, the number of moles of heptane A is equal to 0.25 and number of moles of B, that is octane, is going to be 0.307. By knowing the individual number of moles, I calculated the mole fractions of the two liquids called as a heptane and then the octane, which is referred as XA, and then XB, which is given as 0.448 and 0.582. Then first apply the Dalton's law of partial pressure. The total pressure is equal to the sum of the individual partial pressures, which is equal to PA plus PB. And apply the Rolle's law of liquid mixtures, because PA is equal to PA naught into XA and PB is equal to PB naught into XB. Upon substitution and simplification, I will get the final answer in the form of 72.4 in terms of which pascals? Kilopascals. What is that? It is the total pressure exerted by the mixture of 25 grams of heptane and 35 grams of which one? Octane. Okay. So this is about the which one? The numerical number, how much? It is the numerical number 18th. Okay. So next we left with another one concept, that is the application of which one? The Henry's law, means the gas and liquid solutions that we have to solve. Okay. So that we will discuss in the last session of this particular which one? Numericals. Okay. So thank you.